Hi folks, welcome to the lesson. I'm going to be showing you nice and clearly today how to rotate an object about a center of rotation. So let's crack on and get the job done. Here is our example. We're going to be rotating that triangle 90 degrees clockwise about the point 0, 0. Well, the first thing to consider is the angle of rotation, 90 degrees clockwise. I've put a north line on there. You'll see why when I come to finish the example, why I use a north line. If we have a north line and we rotate that 90 degrees clockwise, that north line will end up facing east. So please, let's bear that in mind. The point about which we are doing this rotation is 0, 0, and that's the origin marked on. Let's put our tracing paper over the diagram. Let's trace our object. And then let's mark in the north line, because that line, when we rotate the tracing paper 90 degrees clockwise, will, if you remember, be facing east. Get something sharp like a pencil to hold down on the center of rotation, and now you're ready to rotate that tracing paper. Take your time, don't let the tracing paper slip, but just rotate it 90 degrees and watch that north line until it's facing east. There, the north line is now facing east. That means we must have rotated it through 90 degrees, and we can see where our triangle has ended up. And we remove the tracing paper, draw our triangle onto the diagram, and we've rotated it 90 degrees clockwise about the point 0, 0. Once we have done this, we can actually check that we've done this accurately. If we draw two lines from the center of rotation to corresponding points, so we pick one of the points on the original triangle and draw a line from the center of rotation to that point. We draw a second line from the center of rotation to the corresponding point on the image, which would be that point there. And the angle between those two lines is the angle of rotation. So if we get our protractor, we can see that that angle is indeed 90 degrees. Here in our second example, the angle is 180 degrees and it's about the point 2, 0. Focusing on the angle first, you don't have to use a north line, I do. If we are using a north line and we rotate that 180 degrees, then it will end up facing south. Now let's consider the center of rotation, the point 2, 0, and there it is marked on the diagram. Put our tracing paper over the diagram, trace around the triangle, which we call the object, and then mark on the north line and place something sharp like a pencil over the center of rotation and get ready to rotate your tracing paper. Try not to let the tracing paper slip as you rotate it, and remember the north line, as it's turned through 180 degrees, should end up facing south. And there it is facing south, so we now know the triangle on our tracing paper represents the image, which is the object after it has been rotated. All that remains to do now is to remove the tracing paper and mark in the image. And there it is. Once again, we can check for our accuracy. We draw two lines from the center of rotation to corresponding points. So that's the first line, and the corresponding point on the image is that point there. What's the angle between those two lines? Well, I think we can probably see that those two lines look like they form a straight line, and that's 180 degrees. Let's put all that together in a recap. Firstly, marking the center of rotation, And if you think it helps, use a north line as a guide. Once you've traced the object, pin the tracing paper down with a pencil or a sharp object, pinning it down on the center of rotation. Rotate the tracing paper through the required angle, and we can check by joining the center of rotation to two corresponding points and measure the angle between these two lines. So in this example, we have a 90-degree rotation. We've joined up two corresponding points to the center of rotation, and we can measure that angle as 90 degrees. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.